Okay, so here it says you draw one card from a 52-card deck. Then the card is replaced in the deck, and the deck is shuffled, and you draw again. Find the probability of drawing a 9 the first time and a heart the second time. Okay, so first of all, what's the key word in this problem? And. So you know that you're going to be multiplying your probabilities. Okay, are these independent or dependent events? Independent is correct. Why? Because the card is replaced. Good. So the card is replaced. So these are independent events. What happens the first time is not going to affect what happens the second time. All right, so it says the probability of drawing a 9 the first time and a heart the second time. So probability of a 9 and a heart, okay, drawing two cards. Okay, so we're looking for the probability of a 9 times the probability of a heart. So again, this, and let me just add to it, it's an and problem where there's more than one event. Okay, because you did see the word and in section 11.4 before, but there was only one event. It was just asking you, can it be both at the same time in one event? So here's an and when more than one thing is happening. You're drawing a card twice. So what's the probability of getting a 9? 4 out of 52. And the probability of getting a heart? Okay, 13 out of 52. If you reduce, that's fine because we're multiplying. So remember what these were already reduced. So this was 1 over 13 times 1 over 4. So now just multiply them together and you get 1 over 52. Okay, so our probability of getting a 9 the first time and a heart the second time is 1 over 52. Nice work. All right, here's another problem. Elizabeth brought a box of donuts to share. There are 24 donuts in the box, all identical in size, shape, and color. They say that because, in other words, you can't really tell what kind of donut is which. And so 6 are jelly-filled, 5 are lemon-filled, and 13 are custard-filled. You randomly select one donut, eat it, and select another donut. Find the probability of selecting a jelly-filled donut followed by a custard-filled donut. All right, so you're finding a jelly-filled followed by a custard-filled. So you're looking for the probability of a jelly and then a custard. Now, does what you do the first time affect what happens the second time you go for a donut? Yes. Okay, so these are dependent events. And you know this because you select it and you eat it. Okay, you didn't pick it up and put it right back down and not, which you shouldn't do anyway, right? Because then you've touched the food. All right, so you're going to find the probability of a jelly times the probability of a custard, assuming a jelly was eaten. Okay, so what is the probability? And again, here are the numbers. 6 are jelly, 5 are lemon, and 13 are custard. And how many donuts are there total? 24, 2 dozen. Okay, so what's the probability of selecting a jelly donut? Okay, 6 over 24. And so now what's the probability of selecting a custard now that you have eaten a jelly donut? Okay, 13 custard over what? 23 donuts are now in the box because you have eaten one of them. There were still 13 custard because you ate a jelly. It didn't affect the number of custard that were in there. Okay, but there are now 23 donuts in that box. All right, we can reduce this. Let's see, 6 goes into 24 4 times. 13 doesn't appear to go into anything, right? So multiplying across, we get 13 over 92. Yes, I would agree. Everybody agree with that? Okay. All right, so 13 over 92 is your probability of selecting a jelly, eating it, and then selecting a custard. Any questions and the difference between independent and dependent events? All right, and then let's look at a conditional probability. So that is 13 over 92. Excellent. Okay, so here you have 8 discs that are in a box, and one disc is selected at random. Find the probability of selecting a 7 given that the green disc is selected. Okay, so notice that 1 through 7 is green and number 8 is blue. And just in case, you know, and this happens, okay? If you have trouble seeing colors, it happens. Now, so they've specifically written it under there so that you don't, you know, get confused. There are a lot of people that have, you know, issues seeing colors. All right, so find the probability of selecting a 7 given that a green disc is selected. So what's the key word in this problem? Given. And that's what tells you that it's conditional probability. So you're looking for the probability of a 7 given that a green is selected. So again, it helps to write these out in words. That's what I was trying to encourage you to do in the beginning when we started doing probability. Our numerator is the number of 7s that are green. And then the denominator should be the number of green discs. Good. Okay, so how many 7s are green? Just one. There's only one 7. And then how many of the discs are green? 7. So your probability is 1 over 7. Okay, so conditional probability. The numerator is how many do they have in common of the two things that you're looking at. And then the denominator is always the number that's given, the information that's given. Okay, so 1 over 7. Fantastic. So we get to end on a fantastic.